Well, Evolution or Creation Seminar. This is session 5 out of a 7-part series. And this time we're going to look at dust everywhere. In the last session, we looked at microevolution and macroevolution. Microevolution is just kind of variation. It's not really evolution at all. And we showed that macroevolution was quite a leap of faith, a wild leap of faith. We looked at Darwin's book and how it has actually caused us to have prejudice, and many horrible things have done in the name of some of this prejudice. We also looked at the cells and DNA and how complex they were. We looked at the 5 pillars from Darwin's book, and we broke them down one by one. And they don't have any valid reason for evolution to have occurred. Before I get any further, I need to ask the Lord to join us. Heavenly Father, I ask that you surround this camp, surround each of us with your Spirit. We don't want to charge through life like I was through this presentation without asking you first into it. Help me as I present, that I present the truth of the greatness of you. I thank you in Yeshua's name. Amen. Thank you, Lem. We looked at the pillars of the theory and found that the pillars had no evolution. I breezed over vestigial organs. Basically, vestigial organs are organs that are leftover remnants of the evolutionary process, which actually that would be sort of de-evolution. But the funny thing is they never thought of those organs as being new things coming, that we're evolving into having something new show up. It's funny. They're remnants. That's funny. They don't even really believe their own theory. And then we looked at the ascent of man and how there's really gaps between the different types varieties of creatures. And I want to look a little bit at steps. You know, the evolutionary process has a number of steps that it has to go through. There's a really big step right at the beginning. I don't know, maybe like a canyon. Rock to life. Now, there's been a scientist who tried to look at, you know, if we were to make synthetic life, what are the major hurdles into creating synthetic life? And it kind of gives us a window on how difficult, how complex life is. So he says, well, first you need a container or a membrane for a cell to keep the bad molecules out and allow the good ones to be inside. And he kind of throws on the side, and to multiply. And then he says, you need a genetic system to control the functions of the cell, enabling it to multiply. And mutate in response to environmental changes. So they kind of throw in some other issues that are in there besides the major ones. Then they said, we need a metabolism that'll take raw materials in. Well, of course, you have to get rid of waste, too. So, you know, they've done some experiments on trying to create life. They were looking at the whole problem because, you know, we have this thing in our atmosphere called oxygen. Oxygen is very corrosive to chemical combinations. And certainly health people are very aware of the things that happen because of oxygen. Well, they started thinking about, we didn't really have a way to have oxygen around and make it work, so let's try a reducing atmosphere where we don't have much oxygen around loose. And so they created this experiment called the Miller-Urey experiment. And basically what they did is they put this very specific set of circumstances to allow certain amino acids to form. Actually, what they discovered by doing this was how difficult it was, that it wasn't nearly as easy. And they had to have a little trap to pull things on the side because if it kept going through the loop, it would get destroyed again immediately. Anyway, they say they have successfully built the building blocks of life. Building blocks. Well, all right, let's think about building blocks. So I'm out in nature, and I go around and I find this cliff, and there's a rock that fell out. And it looks just like a brick. It looks like a building block of a house. Does that mean I'm going to go find a fully built house with electricity and air conditioning and running water, naturally just falling out of a hill? I mean, that's kind of the difference between them having a building block and having a house. Actually, it's become so difficult, the problem of building life on the earth, and that they've actually said, well, maybe it came from outer space. That'll fix it. Well, that actually all that does is pushes the problem somewhere else. They still have the problem. Well, let's say we got our first cell. Well, how are you going to get multi-cells? It's sort of like cells that cooperate, but how do you make that one creature to have a multi-cell? See, it's complicated. They kind of fuzz over this whole problem. At every step of the way is a problem. How do you get organs inside of a creature that are actually doing different functions? Now, this is a favorite topic, male and female. Now, the genetic system that we have, they talk about how if you have this genetics, you try to do things so your genes will continue. So, a goal of evolution is that your genes will continue. Well, if you have an asexual organism, whenever they go along, their genes will completely be continued. However, if you have male and female, if you have sexes, then your genes are immediately split in half. So why would you ever have a system crop up that has half of your genes? Why would we ever have sexes come about? Well, there's all kinds of things, vertebrae, scales and feathers. Why would we ever get those things? And, they say, the scales of reptiles turned into feathers, except for if you look at where they are on the genetic strand, the scales are in one part and the feathers are in another, so you can't really turn scales into feathers. Totally different structures. You start off, you don't have any legs. How do you get legs? Well, legs have bones in them. They have muscles. Oh, how do you get muscles and tendons to hold it all together? And it's actually fairly complex to walk. We've tried to get robots walking. It's only recently we get robots that walk well. Anyway, eyes. How do you get to be anything but blind? They say, there was a light-sensitive skin, and then after a while it got evolved into more and more. But this is actually a big hurdle. And then we have walking and jumping. We take that for granted. But flying is actually a very complex thing, and yet most of the different kingdoms have flying. We have insects. Many of the insects fly. We have mammals that fly, like bats and squirrels that will soar. There's flying fish. And I thought they just glide or something. No, fish, there's some fish that fly. I've watched them on the ocean. They're little bitty fish, but they'll flap their wings and they'll fly for quite a ways. We have plants, seeds. They have numerous ways to stay airborne. My favorite is those ones that spin around like little helicopters. Yeah. Oh, yeah, I love those things. They're all over my yard, though. Anyway. Well, when I give a topic like this, one big question some folk will present is, what about starlight? It takes millions of years for the starlight to reach the Earth, so doesn't that prove that the universe is very, very old? Well, I want to look at that. I don't have an answer. I have 3 possible answers. There may be many others, but I wanted to present you some ideas so that you would have something. Anyway, there's a number of verses that say that God stretched out the heavens. Well, when you stretch out the space of that we have, you would also be stretching out the light. Now, a funny thing that would do is that would shift the light into the red spectrum. That's kind of what we see, the red shift. And they say that the universe is expanding, which it might be, or it might be it was just stretched out. Now, we also have the possibility that the creation was just the local group of stars. Now, I don't particularly like this one because I think it kind of makes your God a small God. And I think we have a big God. Anyway, it says on the fourth day that he made the stars. So it's plural. It's not just our solar system. But there is a quote here from Ellen White in Great Controversy 1911, which she's talking about Job 38:7. She says, "Before the creation of man, angels were in existence. For when the foundations of the earth were laid, the morning stars sang together, and the sons of God shouted for joy." So there was something already created before the creation that we know occurred. So the Ancient of Days, certainly could be very, 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 very old, eternal. And then there's another theory coming out of the book Starlight and Time. Now, this theory is put forward by Answers in Genesis and the Institute for Creation Research. Now, I read this book. It is a complicated book. It was a tough read. A bunch of brainiacs and physicists and whatever, I don't know. They wrote this book, but I kind of gathered out of it what the idea was. We're familiar with the concept of a black hole. A black hole will actually, suck all light in, and it's, there's an event horizon and all that stuff, and it's a dangerous place. Don't go there. But they said that in this theory that we're inside of a white hole. The concept is that time in here goes really slow, and out there it goes really, really fast, so that the light has plenty of time to get here. I don't know. Anyway, I present these ideas so that you have some idea. I mean, not everything's going to be known. Now, I do know the heavens declare the glory of God. Now, there's some sayings. One, that there aren't many atheist astronomers or atheists in foxholes. It's because when they look out there and they see the immensity of the creation we have, they're just in awe. And it leads them to God. It's funny that way. There's so many stars out there that every one of us, everyone on the planet, could have 11 trillion stars of their own. So I started naming mine as Quint 1 and Quint 2 and Quint Centauri 3. There's a verse in Corinthians that was kind of interesting. It says, "There is one glory of the sun, and another glory of the moon, and another glory of the stars. For one star differeth from another star in glory." That's kind of interesting that in his time that they would look at the stars and talk about them being different, each one. Now there are this is a picture of a galaxy from the top. There are some galaxies that have 2 arms. Some of them have 3 arms. There's some of them that have like a big bar in the middle. There's some great variety. God is very creative. Now, it's thought that if you keep spinning these more than, say, 2 rotations, that they would kind of merge together like that. So they haven't really done that. Now, I do want to look a little bit at stellar formation. Because, you start with a big bang, and everything is spreading out. And at the beginning, they would say that all the elements that we have is really hydrogen and then some electrons. Because it's so blasted apart, it's just all tiny hydrogen, and that's it. Now, we have other heavier elements here. So they have a little bit of difficulty figuring out how to make all these heavy elements. So they look at having first generation stars, which are hydrogen, and they generate helium, and then maybe when they blow up, we get some more heavy elements. And then we have a second generation star, and we're around a second generation star because we have all these heavy elements. So they're trying to fix the problem of heavy elements. Now, let's look a little bit at how they believe our solar system might have come about. Now here it reads on figure 3.2, it says, the nebula theory suggests that our solar system may have begun, and this theory says, a shock wave from a supernova, the type 1 star, passed through a nebula, nearby nebula, and a gas cloud. So, all right, let's picture this. You got this cloud of dust in the air, in space, and then you got a supernova, which sends a shock wave over at us. Actually, they always like say if you have like an explosion, somehow you get order out of it. I haven't seen one yet that does. Mostly they have caused disorder. But anyway, they get this shock wave coming along and it spins the nebula. I don't know how that happens. Anyway, and then it spins and it flattens to a disk. You see? I don't know how they do that. That's what they do. And then we have, the planets kind of coalesce as they gather together. They get more gravity, and as the gravity pulls the particles together, they gather together. And then the sun turns on and lightens up, and then pretty much you blow most of the stuff away at that time. But I got to mention something serious here for a minute. The sun is shrinking. Don't get too worried, but I don't know. If it's your God, you might want to worry. Anyway, the sun is shrinking, so that means it used to be bigger. Well, the sun is shrinking at about 2 kilometers a year. Well, I do math. I had almost a math degree, and so I decided to do some calculations, and I said, well, all right, we're 93 million miles from Earth, and there's 1.61 kilometers in a mile, so that's about 149 million kilometers from the sun. So we're shrinking at 10 kilometers a year. Well, if you go out 15 million years, that's 150 million kilometers. We're in the sun. So I would say they say we're 5.6 billion year old solar system. That might be a problem, especially for Mercury and Venus. Now, I did a linear explanation of the shrinking, 10 kilometers per year, but, it was probably larger before. Well, 6,000 years ago, that's not a problem. 4.6 billion years ago, I think you got a problem. Now, Jupiter, is cooling off. It actually loses twice as much heat as it gains from the sun. So how long can you do that? You wouldn't be doing it for billions of years, you wouldn't think. Here's the rings of Jupiter. That's Jupiter, actually. Jupiter has rings, too. Here's Saturn's rings on the next slide. That's a little more complex ring structure. Now, ring structures in general are said to be unstable. So they don't stay around for a long time. And yet these planets have complex ring structures. They should decay and cave into the planet. Now, comets is another problem. I don't know if, how many of you were around during 1986. Many of you probably were. I was quite disappointed when Halley's Comet came around because I read the stories about being able to see Halley's Comet during the daytime. What happened? What a lousy comet, right? I saw Kohoutek come by. I wasn't impressed with Kohoutek. Anyway, the tail that you see on these comets, it's not the direction it's going, like zooming one direction. It's the direction toward the sun. Because see, as it gets to the sun kind of blows its tail off. And they can only do that a few times before there isn't much comet left. So if it comes by every 80 years, 86 years, whatever Halley's Comet comes by, that means it's not a very old comet. We also did a flyby of a comet, and I haven't gotten my video like this thing working, so I'm going to skip that. But so they have a problem. Where do all these young comets come from? Well, the solution they came up with was the Oort cloud. See, astronomer Jan Oort in 1950, he was studying the orbits of several long-period comets, and he hypothesized that there was this great spherical cone of comets on the outside of our solar system, conveniently just far enough away we couldn't see it. All right, so there they are, out there waiting, and something happens, and one of them comes jetting in. You know, gets bumped. Well, no one has seen the Oort cloud. You see, comets aren't really very visible unless they start getting close to the sun, and then their tail lights up, and we can see something. They're sitting way out there. We wouldn't see it. Now, no one has seen the Oort cloud. Even Oort has never seen the Oort cloud. And here's some scientific articles. Oort proposed a cloud of comets surrounding the solar system based on mathematical errors. And Wikipedia says his hypothesis that the comets have a common origin, postulated in 1950, was later proven to be incorrect. I just heard last week on the television, there's a program, a scientific something or other, and they said, oh, and the Oort cloud, blah, blah, blah. I was like, what? 50 years ago, 60 years ago, that was disproven. Well, see, they got nothing to replace it with. That's the problem. You know, you got to say something. So a short period comet, that's one that's considered to be less than 200 years per orbit. And it's expected that they would last less than 10,000 years, because after about 50 trips, they'd be pretty much destroyed. So if we have comets still, that would tend to make you think the Earth is less than 10,000 years old. That's an interesting dating mechanism. I got to talk about Nibiru, I'm sorry. Anyway, Caltech researchers have found evidence of Planet X, and it's 10 times the size of Earth, highly elliptical orbit averaging 20 times Earth orbit, with an orbit that takes 10 to 20,000 years, based on modeling from limited observation. This is off the NASA website. Well, I was thinking about Planet X, and I was thinking, well, all right, I get it. Neptune was planet 9. Then the next planet would be planet 10. Well, X is 10. It's really just planet 10. And actually, since they degraded Pluto to say it's not really a planet, it's a planetoid, whatever that is, they now are saying planet 9 is coming, not planet X. So that's why it's X anyway. Well, you know it's dusty out in space. I don't know, somebody go out there and clean it up. Anyway, NASA, when they send capsules up there, this is a viewing window from one of the NASA capsules, and it's all studded with little indentions from high-speed, very small particles, because there's a lot of dust out there. But what's funny is there's the Poynting-Robinson effect, and Poynting-Robinson effect says that these particles should have been sucked into the sun or one of the planets. Basically, if you have the sunlight shining on one side of the particle and it radiates in all directions, then it would tend to decelerate the particle and pull it into the sun. So it should have swept up the solar system clean of these particles. And of course, the planets themselves have a gravity well, and they should pull in particles. And they've been sweeping the solar system clear for 4.6 billion years. How come we still have so much dust out there? And if we had a lot of dust, you'd think that it landed on the moon. You see, the moon doesn't have an atmosphere like ours to burn up any high-speed dust flying around. It would all just pile up on the moon. Now, the moon landing happened, the first one happened in 1969. They were trying to get it close to July 4th. They missed it by a little bit. They sent Neil Armstrong and Michael Collins down to the planet, or moon, and Edward Aldrin stayed up top. I guess they killed those guys. They wanted at least somebody to come home. So some people have told me, oh, well, they never went to the moon. We have some evidence of they had taken photos and mock-ups of things in different studios, and I believe they did. However, I think they didn't want to have a live television broadcast and have nothing to show. I think they were just ready for a backup show, and they may have had the original just to be a fake. But they've had a number of other Apollo missions, and I think we have very good evidence that they did go. Anyway, scientists had looked at the moon, and they thought not just the dust coming in from outer space that's around, but also the UV and X-rays from the sun hitting the exposed rocks on the moon. They say in the course of the moon's history should make a layer of several miles deep of dust. So they were very concerned about that in the moon landing. So I wanted to read you the transcript of the moon landing, because I think he said some very interesting things when he was talking. So here's Neil Armstrong, and he says, okay, I'm going to step off the limb now. And Armstrong said, that's one small step for a man, one giant leap for mankind. Now he didn't put A in there. One small step for man. It really means amen. What's funny about this, actually, and I learned this because my parents had associations with NASA. Well, sorry, first of all, astronauts are short people. They want to save space and weight, so they got short people. And the ladder, we're going to see it a little bit later, doesn't go to the ground. And there's a good reason why they didn't do that. So he had to actually jump off there, which is actually in a spacesuit and a planet like, on a moon like that with no atmosphere. You don't want to be jumping around. So he was kind of making a joke here that it was a giant leap for mankind, because he had to make a big leap to get off that ladder. So yes, the surface is fine and powdery. That's that dust we're looking for. I can kick it up loosely with my toe. It does adhere in fine layers like powdered charcoal to the sole and sides of my boot. I only go in a small fraction of an inch, maybe an eighth of an inch, but I can see my footprint of my boots and the treads in the fine sandy particles. So, in 4.6 billion years, they have an eighth of an inch, not miles deep. This is also evidence of a young moon. They can't tell me that that moon has been there for 4.6 billion years and an eighth inch of dust. I'm not believing that one. Well, you know, they were very concerned about the dust before they went. They called these duck pads. This is the lunar lander feet. It's a little bit like snowshoes. They were concerned that the ship would sink in. So you can see it didn't sink in, but they thought it would. And here's an astronaut coming down the ladder, as I mentioned, and you could see they expected it to at least go flat to the bottom of the original ship. That's why they had the top part where it would fly off, because the bottom part was going to be stuck in the sand. The ladder didn't even go all the way down, because they assumed they didn't have to go all the way down because they'd be into the dust. So they had this huge jump off the ladder, which was actually a dangerous thing. As a matter of fact, I was living in Florida in 1999, and I saw this article, Moon Disaster Words Ready. All right, well, we've never been to the moon, so they would expect a disaster. So Nixon wrote a speech preparing for a disaster. But it's interesting, they had a specific kind of disaster they were looking for. And NASA would cut off communications with the stranded astronauts. Stranded? They didn't crash land or nothing. They were afraid they would sink into this dust, and they were just going to cut off communications because they didn't want to hear men whining about being stuck there and messing up NASA's public relations. That's a pretty interesting statement there, that they thought they'd lose contact, that they would be stranded up there. Now NASA nowadays has this new thing that they're doing. They're searching for life in space. This is a nugget. This is a tool that we're going to use to go search for life. Here's another one, and Mars Curiosity rover. He's going to look for organic compounds, the building blocks of life. What good there are. So why are we searching for life on other planets? Well, the current search for the life is the effort to validate evolution. You see, the thinking is if we get the right circumstances like we had on this Earth, where we had evolution, supposedly, then we should find that life spontaneously happened on another planet, like Mars or maybe on Europa. They're still looking. Now, I wanted to go over a theory about where I think the comets came from. And there's some others. I'm kind of using other people's standing on shoulders. If short period comets didn't come from slow planetary evolution, then where'd they come from? I think they're the remnants of the flood. See, Dr. Walter Brown in 1980 proposed the hydroplate theory, and it explains many of the geological structures we see on the planet. The fossil record, the shapes of the continents, and even the fact that you would have mountains on some coasts and trenches right nearby. And it has to do with the plates colliding. So that's a real interesting read. He has a book called In the Beginning. I would recommend that book. In the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were all the fountains of the deep broken up, and the windows of heaven were opened. So we have here the great chambers underground, the Tehum. You can see Carl Baugh's Creation and Symphony. He has some good information on this. We have these underground chambers. And somehow, and I don't know how, there was a crack that probably zipped around the globe at supersonic speed to open up and allow the waters, subterranean waters, to burst forth. And with the weight of the land masses, they would shoot up at hypersonic speeds well into the stratosphere, taking with them rock and dirt. And what is a comet made of? Rock and dirt and water. I think they went out of orbit. They went so fast. Now, as it shot up, it would wear away at the edge and get wider, and it would actually push the continents, which were on a layer of water, to move. And we have this look that we see now. So we have this muddy section, a flood that's going on as it spreads, and it's quite the disaster. Now, we also, I'll go into this more in session 6, but there used to be a canopy of water around the globe. Now, if you have this supersonic water shooting up and it strikes the canopy, it brings the canopy down. And we add a bunch of water we didn't have down here. So we have some minor hills and a few small pre-flood seas, but then we have extreme rain. 15 cubits upward did the water prevail, and the mountains were covered. Now, this is when they had small mountains. we were mostly a landmass world. And guess what happens when you have water coming from virtually from space coming back down? It's really cold. Now, I'm not talking about 30 below. I'm not talking about 75 below. How about 270 degrees below? Instant ice age. This is how I believe the ice ages were formed. We have a woolly mammoth in ice, and the woolly mammoth, if you have a snowfall to cover the woolly mammoth, he would rot from his own temperature inside unless you were to freeze him rapidly. The only way to freeze a woolly mammoth rapidly is with very cold temperatures like 270 degrees below zero. And of course, as the plates collide, there's a lifting up of mountains and a dropping down of trenches, which is what we see along the coastlines. Now, I've got some more bad news. You thought the sun was bad. Well, the moon, it's slipping away. You know what that means? It used to be closer. Well, the moon helps make our, it's about 239,000 miles away, and it makes the tides. Now, we get tides twice a day, and if the moon was just a little bit closer, say 6,000 years ago, we'd have a little bit higher tides, no big deal. But if you go 4.6 billion years ago, we're going to have tides that will cover the planet twice a day. Now, you can only drown once a day comfortably. Now, here was an article I thought was very interesting about the formation of our solar system. You know, they used to say our whole solar system took really long times to form, but then they discovered a problem, the gas giants. Because as soon as you turn the sun on, they get blown away. Gas giant planets like Jupiter probably formed in hundreds of years, not millions of years as had been commonly thought, according to a new report. The Jovian giant must sprout hastily in order to survive the punishing rays of nearby stars, well, a star, an international team of astronomers said. Now, we got another problem. I just hate to keep bringing problems to you, but our clocks are getting off. You know, regular clock use, data measures growing as the Earth's rotation slows. Uh-oh. 1996, a little bit later, because we have a leap second, because the Earth is slowing down. It's getting slower. The rotation's slowing. It means that it used to be going faster. Well, if you go back 6,000 years, a little bit of more speed is no big deal. You go 4.6 billion years ago, you got a problem. I know what happened to the dinosaurs. They were flung clean off the planet. Well, see, the problem you have when you spin the Earth too fast, because the wind, it causes the trade winds. And it uses the Coriolis effect that causes this rotation in the atmosphere. And right now, it's okay, the winds, but if you spin it up a whole lot more, you might have 300-mile-an-hour winds all the time. That's a little tough on the planet. Now, this is a picture of iron filings with a magnet. Actually, I found that there's actually two uses of iron filings, and this is one of them, to show us magnetic fields. Another one is for oxygen absorbers. This iron filings absorb oxygen. So you get those little oxygen absorbers, they have iron filings in them. Anyway, the magnetic field around our planet, it's getting weaker. Uh-oh. You know what that means? It used to be stronger. Well, if we have our magnetic field a little bit stronger, say over 6,000 years, it's not a problem. But you make it really strong, and you start to get magnetic storms. Serious problems to any electronic devices like people. Now, what they try to say is that our magnetic field is getting weaker and it's going to flip. Now, I have had a compass for quite some time, and it's never flipped the pole on my magnet. Has anybody ever heard of a compass having its magnet flip its pole? So where did they get the idea that magnets can flip their pole? Well, see, they see it's getting weaker, so they say, well, all right, because it's getting weaker, maybe it flips every so often and gets stronger again. But there's no science there. Actually, you have to have some outside force. Now, if the sun did something funny, it might be able to cause our magnetic field to flip. But they're talking about the sun's magnetic field flipping. Well, what would cause that? I mean, it's kind of thermodynamics, laws. Things don't just happen. So looking at thermodynamics, we're going to say no matter or energy can be created or destroyed. Well, right there, a bunch of stuff created into energy and matter. You know, we have huge amounts of material that create huge galaxies and amazing structures out there. And they think all this happened just by chance, that we're at the right spot to allow water to be in 3 phases, that we could have life on this planet. And they say, no, we started molten and we developed this complex structure of our planet. Or maybe it came straight from the Creator's hand. Designed perfectly. Beautiful world. Actually, I look at that picture and there's no clouds at all. That would not be a good world. Anyway, the second law of thermodynamics is everything tends toward disorder. But we see order all over the place. We see galaxy order, solar system order. It goes on and on at the largest and smallest. Well, I'd like to do a scientific experiment. And my experiment is going to take 4th graders and the football team and a merry-go-round. So we're going to put the 4th graders on the merry-go-round, and we're going to have the football team spin the merry-go-round. It's in the name of science. It's okay. So at first, in phase 1, there's lots of noise as the children yell, faster, faster, faster. And then we reach, as we spin the thing up, we reach about 30 miles an hour and we reach phase 2, at which point it gets really quiet as the children concentrate to hold on. But we're going to spin her up faster, faster, and then in phase 3 it starts getting noisy again as they start screaming, stop, stop, stop. But we're going to spin it up some more, and we reach phase 4 at about 100 miles an hour. And as the children fly off the Ferris wheel, we notice an interesting fact of science, and that is that if the merry-go-round is going that way, that when the children leave, they're going that way. It's called conservation of momentum. So if you think about the Big Bang, any rotation is conserved with all the things that fly out from it. So our solar system should all be spinning and rotating the same way. We come into our planets. Well, I hate to say we only have 8 planets anymore. I don't know if 9th is going to be showing up or not. We have 63, 64 moons. I don't know, that number changes frequently. They talk about Pluto as a planetoid, and they got 90, 377, Sedna, 2003, VB12. I mean, I don't know what all those, that's different objects they found, not quite planets. But anyway, in our planets, we have Venus and Uranus, and possibly Pluto rotate backwards from all the other planets. How'd that happen? How did we get a solar system where we have 6 of the 64 moons rotating backwards? Saturn, Neptune, and Jupiter have moons that orbit in both directions. If I can do that. Right? So how do you get a solar system that's like this? I think in the beginning, God created the heavens and the earth. And the earth was without form and void, and darkness was upon the face of the earth, face of the deep. And the Spirit of God moved upon the face of the waters. Waters. You know, Carl Baugh talks about the possibility that the planet was first formed as water, and that it was sort of a blob of water. And he thought that you could take hydrogen, and from that synthesize the elements up to oxygen, and then from oxygen synthesize the elements on up to 100 or wherever we're at. The next statement is, and God said, let there be light, in Genesis chapter 1. Well, it's an interesting thing happens when you have water and you put sound on it. If you have some certain setup, you can use some transducers and send sound into water, and you can create light. You can create light from the sound being forced in. So you could get some interesting water speakers. That'd be interesting. You can actually go the other way around and send laser light in to water and get light. Laser light and get sound, sorry. In Livermore, California in 2009, high-frequency sounds have been converted into light for the first time, according to scientists at the Lawrence Livermore National Lab. By reversing the process that converts electrical signals into sound, the researchers believe they have discovered a new way to enhance the way computer chips, LEDs, and transistors are built. So they used a laser to create sound. Now, they also have another interesting thing that they've discovered is a thing called sonoffusion, where they can take sound, and you know where that light is. They're not really sure why that light exists there. They think it might be causing fusion. So this could be the way you could speak at this water earth and create all the elements that we have today. Now, I was looking at Genesis, and, you know, sometimes you see things you never saw before. And I saw creation, you know, God saw the darkness. And there were several things in there, and I thought, let's compare that to Abraham. Well, Abraham saw that Sarai was barren. That's darkness. And then God divided the darkness from the light. He called Abraham to separate. And then he spoke to the darkness. And he spoke the prophecy about the seed to Abraham. And then God named the dark and the light, and God named Abraham and Sarai and Sarah. I don't know. Maybe it's something about how God works. So as I was mentioning, hydrogen and oxygen could have been used to build the entire periodic table. Now, there's interesting materials from Robert Gentry. He has a website out there, halos.com. And he has written some papers dealing with the Big Bang Theory. And in these papers, he put them out on this the server that's Los Alamos National Laboratories, and they censored his papers because it gave the idea that maybe the Big Bang has some flaws. Anyway, one of the things he talks about is that the energy from the Big Bang proves that there would be a huge loss of energy with the expansion that they're talking about. So I'm going to skip this and jump over to we are forced to conclude two contradictory principles hold. First, there is conservation of energy, and second, the energy of the universe is not constant. I like to invoke the Red Queen whenever I find something like this. It says, why sometimes I believe as many as 6 impossible things before breakfast. Well, in summary, we found, well, we didn't go too much into Gentry's papers, but you might look those up, that he falsified the Big Bang Theory. We looked at dust and how having dust present is a problem. We looked at dust on the moon. We looked at comets and how they're a problem, and they actually date the solar system to be young. We looked at the shrinking sun, the orbit of the moon getting larger, the magnetic field getting weaker, and the planets cooling. Heavenly Father, we thank you for showing us your great universe that you've created and leaving your fingerprints there so we can see that it had to be you. It wasn't natural causes. We thank you.